Okay, remainder and factor theorem. Let's try this question number 1. It says the polynomial f of x is defined by f of x equals 12x cube plus 25x square minus 4x minus 12. First part says show that f of negative 2 is equals to 0 and factorize f of x completely. So we just have to plug in the value of x, which is negative 2, and then use calculator, and this is equal to 0. And when it says factorize it completely, we have to solve for the polynomial again and use long division method, first of which is to do it by hit and trial. So in this case we already know that when x is equal to minus 2, it is a factor because it leaves a remainder of 0. So factor should be x plus 2 is equals to 0. So I'm going to divide this, which is 12 x cube plus 25 x square minus 4x minus 12, and we're going to divide it with x plus 2. So solving for long division, to get 12x cube I have to multiply it with 12x square. So x into 12x square is 12x cube, 2 into 12 is 24x square. Then we change the signs and add them. This is x square minus 4x minus 12. Second step, to get x square we multiply it with x. This is x square, 2 into x is plus 2x. Change the signs and we add them. Last step, to get negative 6x we multiply it with minus 6. So x into minus 6 is negative 6x and negative 12, and when we change the signs we add them. This is 0. So basically this polynomial right here is a product of these two, x plus 2 and this. So now we can write f of x is equal to x plus 2 times 12x square plus x minus 6. This is x plus 2, and on the other side we do midterm breaking. So let's say that is 12 times 6. So we have to think of two numbers whose product is 72 and sum is x. So 12x square plus 9x minus 8x minus 6. If I add these two I get 1. When I multiply these two I get minus 72 x square. So x plus 2, taking out common, this is 3x. I'm left with 4x plus 3. When we take out minus 4, minus 2, and left with 4x plus 3 again. Combining the two, I get x plus 2 times 4x plus 3 times 3x minus 2. So this has been factorized completely. B part says given that 12 into 27y and so on. Okay. So this is given that this is 12 times 27 power y plus 27 into 9 power y minus 4 into 3 power y minus 12 is equals to 0. So it says state the value of 3 raised to power y and hence find y correct to 3 significant figures. So I have to state the value of 3 raised to power y. So what do? We do it by comparison. We had the original question, and if you can just compare it, you see these values are in place of x. 12 was already there, 25 was already there, minus 4 is already there, minus 12 is already there. So if I could write it as 3 cube y, and this is 3 square y, and this is 3y, and we can see that 4x. So basically x is equals to 3 raised to power y, and you could also rearrange these. So 3 raised to power 5 is basically equal to x. 3 raised to power y is equal to x. When we write this, we have different values of x from the given factor, which was x is equals to minus 2, x is equals to minus 3 by 4, and x is equals to 2 by 3. So once we write these, 3 raised to power y is equals to negative 2, 3 raised to power y is equals to negative 3 by 4, and 3 raised to power y is equals to 2 by 3. These two are rejected because 3 raised to the power anything cannot be a negative number. And we solve the last one. This is y is equals to log of 2 to base 3 to base 3. And then we use our calculators. This is 2 by 3 to base 3 is negative 0.369. Any confusion? Let's try this question number 2, which says the polynomial ax cube plus bx square plus 5x minus 2, where a and b are constants, is denoted by p of x. It is given that 2x minus 1 is a factor of p of x, and that when p of x is divisible by x minus 2, a remainder of 12 is left. So 2x minus 1 is a factor, that means remainder will be 0, and when it is divided by x minus 2, remainder is 12. Let's write the original question. Which is polynomial equals ax cube plus bx square plus 5x minus 2, and given data is that when it is divided by 2x minus 1, remainder is 0, and when it is divided by x minus 2, remainder is 12. So now let's form equations and find the value of a and b. So when it is divided by 2x minus 1, that means x is equals to 1 by 2. So p of 1 by 2 is equals to a 1 by 2 cube plus b 1 by 2 squared plus 5 1 by 2 minus 2, and the remainder is 0, so you plug in 0 right there. A over 8 plus b over 4 plus 5 by 2 minus 2, and then we simplify the equation. 0 is equals to a by 8 plus b by 4, 5 by 2 minus 2 is 1 by 2. I'm multiplying the whole equation with 8 to get rid of the denominators. 0 is equals to a plus 2b plus 4. So this is equation 1. And when we use the second factor, x minus 2 is equals to 0, x is equals to 2. When we use x is equal to 2, remainder is 12. The polynomial, when you plug in 2, this is a into 2 cube plus b into 2 squared plus 5 into 2 minus 2. The remainder was 12 is equals to 8a cube plus 4b plus 10 minus 2. So we get 8a cube plus 4b, 10 minus 2 is 8, take 8 on the other side, this is 4, and equation 2. I'm going to solve simultaneously, and a slight correction, this is 8a. So I can divide with 4 on both sides. This is 1 is equals to 2a plus b. Equation 2. So if I make b the subject and solve these two equations, this is 1 minus 2a is equals to b, naming it equation 3. Now substitute equation 3 in equation 1. That would be 0 is equals to a plus 2, and value of b is 1 minus 2a plus 4. So we substituted this equation 3, 1 minus 2a in equation 1. The only unknown is now value of a. So that is 0 is equals to a plus 2 minus 4a plus 4. Adding these two is minus 3, take them on the other side positive. 3 is equals to 6, so a is equals to 6 by 3 equals to 2. When a is 2, b should be equal to 1 minus 2a, 1 minus 2 into 2, so 1 minus 4 equals minus 3. So a 2 and b is minus 3. Second part says when a and b have these values, find the quadratic factor of p of x. So, polynomial is now a is 2, so that is 2x cube, and b is minus 3 minus 3x square plus 5x minus 2. And it said when the a and b have these values, find the quadratic factor. We are known with the 2x minus 1, which is already the factor. So now we go for long division and use 2x minus 1 as one of the factors. So 2x minus 1, and inside is the polynomial. So we go for long division. To get 2x cube, we multiply it with 2x square. So 2x cube, then with minus 1 is negative x square. Change the signs, get rid of this, and minus 2x square, copy the rest of the expression. To get minus 2x square, we simply multiply it with x minus x, and I get minus 2x square. Minus into minus is plus x. Change the signs, and this is 4x minus 2. To get 4x, we multiply it with 2. So 2 times is 4x, minus 1 into 2 is minus 2. Change the signs, and this is 0. So we were interested in the quadratic factor. So basically polynomial is now equal to 2x minus 1 times x square minus x plus 2. And finally this polynomial has a linear and quadratic factor, and that is your answer. X square minus x plus 2. Okay, in question number 3, polynomial is given which says p of x is equals to x power 4 plus 3x cube plus ax plus 3, and it says when it is divided by x square minus x plus 1, it is divisible by this, so factor must be 0. And when we look at it, x square minus x plus 1, it has no midterm breaking, there is no linear factor, so we'll have to divide it with the quadratic one. So x4 plus 3x cube plus ax plus 3, and we divide it with x square minus x plus 1. So first is x4, we simply multiply it with x square. X square into x square is x4, negative x into x square is negative x cube, 1 into x square is positive x square. Now we change the signs from plus to minus, minus to plus, plus to minus. When you add these, we get rid of this. Cube and cube is 4x cube. There is no term in x square, so it is just negative x square plus ax plus 3. Now we have to get 4x cube. So multiply it with 4x to get 4x cube. This is negative 4x square. 1 into 4 is 4x. So when we add these, subtract these, we change the signs, get rid of this. Adding these two is plus 3x square, and I'm taking out common. This is a minus 4 into x plus 3. Okay, last step I have to get 3x square. So I should multiply it with positive 3. Get 3x square. When you multiply with x, this is negative 3x, and with 1 this is plus 3. Now we know that this is the last step, so basically positive to negative we eliminate this, negative to positive this should be eliminated, and positive to negative we eliminate this. So I can actually say that a minus 4 is equals to minus 3. In order to eliminate it, a is equals to 4 minus 3 and a is equals to positive 1. So after having the value of 1, polynomial is now, I'm rewriting this, polynomial is x4 plus 3x cube plus x plus 3. And second part says when a has this value, find the real roots of the equation p of x equals to 0. So may I write this as the product of these two factors. One was already given, one is now in front of us, which is x square minus x plus 1 times x square plus 4x plus 3. And now we know we can do the midterm breaking for second one. That is x square plus 3x plus x plus 3. When we add these two we get 4, multiplying these two we get 3x square. So x square minus x plus 1, taking out common, x plus 3 plus 1, x plus 3. X square minus x plus 1, and rearranging them, and we get x plus 1. So this is the final factorization, and value of x would be x plus 3 is equals to 0, x is equals to minus 3. On the other hand, x plus 1 is equals to 0, s is equal to minus 1. Any confusion? Okay, question number 4 says the polynomial p of x is defined by p of x is defined by x cube minus 3ax plus 4a, where a is a constant, given that x minus 2 is a factor. So if x minus 2 is a factor, a remainder should be equal to 0. So I'm using x minus 2, value of x would be 2. So when we substitute this value, 2 cube minus 3a into 2 plus 4a, we know that remainder is equals to 0. In this case, 0 is equals to 8 minus 6a plus 4a, taking 8 on the other side, minus 2a, a is equals to minus 8 by minus 2, value of a is equal to 4. Second part says when a has this value, factorize p of x completely. So we rewrite the polynomial, which is x cube, and plug in this value right here. 3 4 times is 12 minus 12ax plus 4 4 times is 16. This is 12x. So we have to factorize this completely. First factor is known, that was x minus 2. It was given x minus 2. So this is x cube minus 12x plus 16, which is divided by x minus 2. To get x cube, we multiply it with x square. X into x square is x cube minus 2. So this is minus 2x square. We change the signs and we add them. So we get 2x square minus 12 plus 16. Second, to get 2x square, I multiply it with 2x. So x square into 2x is 2x square, minus 2 into x is minus 4x. We change the signs and this is minus 8x plus 6. Sorry, that was 16. Okay, so last step, to get minus 8x, we multiply it with negative 8. That is minus 8x. Minus 2 into this is plus 16. Change the signs and remainder is 0. So p of x is now product of these two factors, which is x minus 2 times x square plus 2x minus 8. And now this is 8. 8 is 4 2 times 8. So x square minus 8, and factors are 2x and minus 2x. X minus 2, take out x is common, this is x plus 4, minus 2 is common, this is x plus 4, and last step, x minus 2 times x minus 2 times x plus 4. It has been factorized completely. And B part says find all the roots of the equation px square is equals to 0. So you see, we just substitute x square in place of x. So when we already have these roots, if I just plug it in this one, I'll get x square minus 2 into x square minus 2 into x square plus 4. So to get all the roots, we equate them with 0. X square is equals to 2 and x is equals to plus minus square root 2. And for x square plus 4 is equals to 0, this is x square is equals to negative 4. Square root both sides, x is equals to plus minus 2 iota. Any confusion with this iota? Okay, so question ends here. The next question says find the quotient and remainder when 2x square is divided by x plus 2. 2x square is divided by x plus 2. So we multiply it with 2x. X into 2x is 2x square and 2 into 2 is plus 4x. Change the signs, get rid of this. This is negative 4x. To get negative 4x, we multiply it with negative 4. X into minus 4 is minus 4x. 2 into 4 is minus 8. Change the signs and this is plus 8. So the demand was find the quotient. Quotient is equals to 2x minus 4 and the remainder. Remainder is equals to 8. Question number 6. Question number 6 says the polynomial ax cube. Polynomial is ax cube minus 20x square plus x plus 3, where a is constant, is denoted by p of x. It is given that 3x plus 1 is a factor. So 3x plus 1 is equal to 0. Remainder would be equal to 0. Find the value of a. Okay. So when it is a factor, we use this. So 3x plus 1 equal to 0. 3x is equal to negative 1. X is equal to negative 1 by 3. P minus 1 by 3. A minus 1 by 3 cube minus 20 into minus 1 by 3 squared to minus 1 by 3 plus 3, and remainder is 0. Negative a over 3 cube is 27. This is negative 20 by 9. Then we have negative 1 by 3 and 3. Taking this expression on the other side, a by 27, and using calculator for the remaining numbers. 3 minus 1 by 3 minus 20 by 9 is positive 4 by 9. 9 1 times, 9 3 times, and 3 4 times is 12. So a is equals to 12. Second part demands when a has this value, factorize it completely. So p of x is equals to 12x cube minus 20x square plus x plus 3. And we already have one factor, which is 3x plus 1. 12x cube minus 20x square plus x plus 3, and the factor is already 3x plus 1. So in order to get 12x cube, 3 4 times is 12 and x square. So 3 4 times is 12x cube. This is plus 4x square. Change the signs and subtract them. Minus 24x square plus x plus 3. To get negative 24, 3 8 times is 24. So negative 24 and x to get x square. With 1 this is negative 8x. Change the sign. 9x plus 3. To get 9x, simple 3 times is 9x. 1 into 3 is 3. We change the signs and get rid of this. Now polynomial is product of these two vectors. 3x plus 1, 4x square minus 8x plus 3. Midterm breaking for the second bracket. 4 3 times is 12, so 4x square, and 6 and 2 gives us 8, and product gives us positive 12. 3x plus 1, and taking out common 2x, left with 2x minus 3. Minus 1, left with 2x minus 3. Last step, 3x plus 1 into 2x minus 3, and these two 2x minus 1. So factorized completely.